it. Maybe we will. All right. So the goal for you, Zoom, or recording, we're gonna be talking about how 61B is designed, get some feedback, talk through. So anyway, classes, they could be anything. Like you could decide to do pretty much anything, especially if you're tenured. And so I just want to note that 61B, like we're mostly done and we have a very strong sense of what it was and what we did. And I feel like we achieved great things and we'll reflect on those in a bit. But I want to reflect on like what other things we could have done in 61B. Like I want to think about like, how was 61B designed? Because I can get some feedback from you. I'll get some sense of what you thought. You know, what do you think works with the class? What's not so great? What's the bigger system in which 61B is embedded? What are some of the interesting, extrinsic challenges that have nothing to do with curriculum that are kind of interesting? And what else could 61B and like any other class ever be? I think it's kind of a fun conversation. So we'll see how it goes. If we have time, I'll talk a little bit about the bargaining thing, but maybe. All right. So I want to note that as an instructor, I have pretty much total control to do anything, right? I could do anything. We could do all kinds of strange things. Like we could have no exams. I could do that. I mean, not having a final is challenging, but you could, right? Some classes do. We could have no labs. And I'd say most data structures classes don't have them. I'll talk about why labs exist in the first place in a little while. We could have no assignments that have any kind of theory. And in fact, earlier version 61B, I didn't. Like there was no homework where you sat down and did some like plug in the numbers into the graph and see what happens kind of assignments. We could have no deadlines at all. And I think I've had various, like I have relatively flexible deadlines as they go. I took a Fourier and Laplace transforms class when I was in college from a guy who was, he was like in his mid to late 90s, but still teaching classes, which was pretty awesome. And he had a rule that there were no deadlines for the homeworks. And so of course, at the last week of class, he just got a giant stack of homeworks that I'm assuming he just didn't grade. We could have no programming assignments where we run code. Like you could write code, but never run it. And I should note that Dijkstra, he said this was a good idea, the Dijkstra's algorithm guy. He's actually written a lot of stuff up on his UT page. I technically overlap with Dijkstra barely, but I wasn't even a CS major, so I never met him or anything. But he said implement it, right? So he's talking about like, hey, maybe we don't want to teach programming as something that's like, writing code. It's really about formal proofs, which is what he was into. He was suggesting maybe you would have your class have write their programs in a language which has never been implemented. So that way you're never tempted to test your programs, right? So this is like a totally different view than what I do, which is I get you guys to write tests and you iterate on your code. I think it reflects practice in industry pretty well. Yeah, Dijkstra had the opposite opinion. Point being that if he ran this class, maybe you would have never actually run your code. You probably would have enjoyed it less. We could do assignments that are all partner or no partners. Exams could have partners. And I mean, it's a weird idea, but I've read it in book. Anybody here ever taken an exam in a group? Tell me, what was it? Mm-hmm. Oh, okay, cool. Yeah. Did you get, like, it counted towards your grade too? It's like a real deal. Cool. Trig exam, you said? Cool. Next, yeah. High school geometry. Interesting. Geometry teachers are all in. Yeah. Oh, okay. So you're given the okay to cheat during COVID. Yeah, during COVID. Yeah. Is it the same problems both times in Stat 20? Yeah. Oh, okay. Got it. Oh, so it's possible you do it twice. That's interesting. Huh. Why is it possible, but not always the case that you get the same problem twice? Like if you get your apartment. Yeah, that's sort of interesting though. Right. Okay. I wonder if there's any variance in terms of the grades. Like, do the groups get 100% or not 100%? 100 individual, -1 on the group. Okay. Yeah. Right. So there's possibilities. I haven't ever done this, but I could. Yeah. There's all kinds of things you could do. We could teach in other languages. I had a TA who was sort of jokingly suggesting we all move to Rust. I don't know what that means exactly, but we could write in another language. Like C++ is not an uncommon data structures class language. Like Stanford uses it in theirs. Not that much worse as a language for a data structures class. It's like some advantages, but mostly disadvantages in my opinion. We can also do Python. Like I've done this class in Python the first 5 weeks before. We can also do it in a weirder language like the ML languages, like OCaml. Wonderful language. I really like it. Kotlin, which is sort of like a better Java, but less popular. And yeah, so all these things are possible. Yes. We've landed what? Rust? But yeah, we've landed on what we've landed on. So I'm gonna talk a little bit about the history. Okay. All right. So just be aware though, people can do whatever they want. And hopefully, I don't know, anybody had a super weird class at Berkeley that like breaks the rules in some super interesting way other than the Stat 20 pair quizzes? Curious. No? Okay. I'm sure we have one of the weirder lateness policies, right? Although maybe other people are doing it now too. Yeah. Yeah, what do you got? So Math 54 had originally you can't ask any questions about homeworks, you mean?
Yeah.
Okay. Well, that would be one way to build independence, right? We had an AI who someone submitted a feedback report on an AI saying they spent 3 hours with me on project 3 and it was great, but I was a little nervous because makes me think that student hadn't learned enough stuff by this point to need 3 hours of help. If you're that student though, I mean, I'm glad you're getting through the class, but it's a little nervous about it. That's the opposite opinion, is the Math 54. You just can't answer questions. Okay, or ask questions. All right, let's talk about the history of 61B a little bit. So 61B's existence since, that's actually, I think it is spring 1994. It's the first time. And before that, it was 60C. And 60C actually goes back to 1986. It's a pretty interesting document. Oops, I got to log in. Which you should also have accessible because you have a Berkeley login, which is the history of introductory computer science. Maybe you'll find this kind of fun. This is all from a class called 302. So prior to 1983, there were 5 lower division computer science courses. Here's how they were. And there was originally this CS50 and 55, yada, yada. And all this stuff was real. And it's kind of cool to read this history and see like, for example, what did they say about labs? I didn't know this until I read this recently. I say labs. Right, we in CS3 and 61A, B, and C all involve the use of closed labs. We adopted lab sections in 1983 as a response to overloaded computers, whatever that means, right? It's like, doesn't even make sense in the modern parlance. And labs have existed since 1983 because of the overloaded computers. Now, if you look at this equivalent class at Princeton, for example, which is 226, there is no lab thing, right? Like all they have is discussion sections and assignments. So precepts are discussions. Here they are. And there's assignments, but there's no lab. Okay. But here there's a lot of labs because in 1983, we had some overloaded computers. Okay. So these kind of random choices happen and seem to work out well. What's that? Yeah. It said logo. Oh, right. Yeah. You know, funny. We should do logos. Yeah, it's a little prettier. For a long time, they had my videos from their assignments like on their page, like 4 or 5 years after I left. And I would meet random people who were like, hey, I know you. I was like, I was at Google one day and I met someone who, that's fine. I met someone who recognized me from the videos because they were a student at Princeton. Anyway, now 61B was originally in C++ for its first few years, and also the 60C class that preceded it. And it used to go, by the way, A was like 61A, except it was in Scheme. 60B was the machine learning C data or machine structures, kind of low level stuff. And then you went back to a high level language for 60C. That was the old days. Anyway, we switched to Java in 1997 and we've been there ever since. And it's still the most popular language that has the features that it has. And I actually really like Java. I think it's a pretty good language personally. So I don't know. I know a lot of people hate it because it's very verbose, but I think it's great. It helps you keep track of what's going on. That's how I think about it. Okay. Now, what about 61B? Maybe this stuff's fun. I don't know. Yeah. In modern times, I'll say there's been 4 61Bs. There was my version, which is the only surviving version at the moment, other than the summer version. So in this approach, I'd say one of the distinguishing features from other 61Bs that existed right before is I like to have 1 or 2 really long real world project that ties into data structures. So like NordNet, you got to be extending the time series, or you got to make a time series class, which extends a map of some kind. And in project 2B, you have to figure out how to implement a graph. So the things you're doing are very data structures-y. Project 3, maybe a little less so. And then everything else other than that, like everything tries to be very tight with the lectures, like DEX is the lectures, or homework 0 and A and B, or project 0. Like that's all related to that first couple weeks of the class. And the summer class, I should say, is pretty similar. And in the recent past, it's also had Gitlet. I don't know if Gitlet will survive the summer. Who knows? But it's also been a class that focuses heavily on data structures. Now, Hilfinger, who retired last year, had a kind of different philosophy, which was having 4, I would call them rather large real-world projects. And in his class, there's actually a lot of variance in the grades on the projects themselves. Whereas in my class, the assumption is that everybody gets most of the points or almost all the points. I'm still working on that with project 2 a little bit. And the reason that I found the Hilfinger, I mean, this is another philosophy, and I don't think it's wrong. I feel uncomfortable having students spend too much time on projects, which happens a lot with the Hilfinger version. Okay. Now, another thing that's very different is that Hilfinger's projects are often, I mean, they're designed around the data structures content, but it's not as focused. Like it tends to be some sort of bigger system where the data structures context is, or content is a little bit less central, right? So you're not necessarily implementing a graph, okay? Whereas I like to try and do stuff more like that. And then there's another defunct version, which was the most popular version, or like the other version of the class, the spring version back in the day, which was Jonathan Shuchek and Kathy Yellick's version, which focused a lot more than I do on implementing data structures. So like you guys didn't really implement, let's say, like heaps or priority queues. You didn't implement, let's say, Dijkstra's algorithm or a priority queue that has changeable priorities, which is a component of Dijkstra's algorithm. And I think that's fine, right? I think we learn a lot of that, but I want to have a little more excitement. There's a lot of trade-offs here. Like, how much do I have you build the thing? Because you get more understanding of the thing when you build it, like a priority queue. But there's only so much that you can do, right? I do a little bit with Dex and Project 2B, but not too much. Any questions about that? Yeah. Every semester, I'm gonna talk about all the changes I made, and yeah, I have some changes in mind for the future. I'm always iterating. Oh, next time I teach. I don't know. What are you gonna do? Good question. Yeah, I haven't decided. Anything else in that thing? I had the entire summer to come up with a plan to these. I'm not worrying about that until I finish the finals. I'll put another again. Yeah, all right. There's another question over here. If you have any questions, I'll be available. Oh yes. I'm implanting myself in Leiden University and figuring out what they do there. I have no idea. So was another question, or was that it? Same one. All right, cool. Yeah. Okay. So I'm gonna tell you a little bit. I'm not gonna say everything on these slides. It's more of a historical document. But the first time I ever ran my own 61B was spring 15. And one thing that was really interesting is I let my TAs, because I didn't have undergrad TAs before, but I had my TAs help build projects with me. And one thing I learned is that it's really, really hard for TAs to build projects that are good. Like, they're not bad, they're cool, like good ideas, but like really getting all the details right is very hard. Even I falter, but this is the semester I learned, don't just hand over project creation to TAs. And so we had these set of projects. You can look at them if you want. But one thing that I noticed is I was taking a cue, and I'll talk more about this, from students who said they liked having at least some super hard project. And so that one that semester was Gitlet. That was the first IgnnoredNet, by the way. It's very different than the current version. But Gitlet was the project 2. And this was created by my TA, Joey, more or less on his own, because I was very tired after building IgnnoredNet. And this project was just super hard. There was no testing that we provided. There were no tips on a key thing in that project called persistence. And like that was my big learning experience, but everybody got through it. But man, it was tough. Okay. So next semester, I made pretty big changes. So I'm gonna call it 1.0 to 2.0, which was I wanted to I just, in that previous year, there just wasn't enough data structure stuff in these projects. There's actually an earlier 61B I was part of, which was fall 2014. I'll tell you a little bit about that because I think it's pretty interesting. Sorry. My own narrative. So fall 2014, 61B, I co-taught with Paul, and we had our own separate lectures. So he had his, I did mine, but we had the same assignments. And one thing I did is on all the projects, the Hilfinger's big projects, I made these getting started videos that maybe I don't know, I clicked on it recently. So this implies I've showed it to you before, but yeah, so we had a big project and I would make some silly video with some silly intro. That's really fun. Running Oxford. I don't know why that did that, but I had a lot of time on my hands back then. The other thing that's very different about teaching these days is I used to be like the super poster on Ed or Piazza. These days I post relatively little because I'm doing everything else. And Anyway, so this was really the second time that I taught, but I was running my own show. Okay, so the next year, observing in the previous year that we weren't doing enough data structures implementation, I decided to shift things a little more towards building data structures. And that happened in the labs and a few other places. And the other thing I wanted to do is, right before we got to the data structures content, I wanted to have a big real world project that had the Hilfinger flavor. And the idea is it's not data structures because it comes before data structures. So imagine doing build your own world, but at a smaller scale at roughly week 6, where it's just like, I'm going to throw you into the complexity mine at that point. So in 2016, there was build a text editor, and that assignment helped inspire John Osterhout's book that I used this semester in an indirect way. And then 2017 was building a database, and this is actually a pretty good project. I like this project. Anyway, that was CS2 or 61B2. Then we had the third version of 61B, which I'd say was inspired largely by this roundtable I held. This is a very formative moment in my teaching one-on-one. So I basically got together, I invited people like, let's all get together in a room and talk about the experience with the big project, which I believe that semester was I don't remember if this happened this year or this year, one of those two. And the idea was, I didn't tell the students, I'm taking you from each quartile, but I knew roughly how people were doing, looking at their project grades and their exam grades. And I didn't want to get people in a room together where, you have someone who's been programming since they were 7 and is very, very good at it, with someone who just started and they took CS10 and 61A and kind of hard time. Getting those people in the same room, I think that it would just feel weird. So what I found is that with the big project, the back-breaking, dropping you into the complexity hole project, the top quartile were like, we really liked it. It wasn't such a big deal. Like, we got through it. It was pretty smooth sailing. The second quartile said, it was super hard, but I liked it. Like, it pushed me to my limits, but I felt good. The third quartile, the general vibe in the room is that, I was working on this so much that I was having dreams about it. And you might have had that experience in this class. I think it's a good thing to happen when you're learning, because it means that we're really training you and changing your brain. And they felt good when they were done, but they were just wrecked. And the fourth quartile, they had a situation where they didn't even get that payoff at the end, where they were like, I learned something. They had a miserable experience. They often didn't finish. They didn't really feel like they got anywhere. And that's a huge bummer. Okay. So what I decided from that day forward is I would tone down the project so that, it's going to shift down a little bit, and that we're going to have the fourth quartile, maybe hopefully have the third quartile experience. Okay. So that brought me to 61B version 3. So in this case, we created a new project called Bear Maps. And this was really closely tied into the course content. Now, Bear Maps had a lot of different incarnations. There was a version that had a quad tree instead of a KD tree, blah, blah, blah. But my favorite version of this project was a very scaffolded project that happened when NordNet happened. The first part, you built something called a KD tree, which is another data structure that you've never talked about, so I took it out. It's a multi-dimensional version of a binary search tree. So if you have data that has X and Y coordinates, or X and Y and Z. And there was no public autograder. You just had to show that it worked. Then you also had to build a priority queue that had a new operation called change priority, and it also had no autograder. And these two, you just had to have confidence that it worked. And there was no way to go back at it, but people generally did pretty well. Then you had to use your priority queue to implement the A* algorithm, that variant of Dijkstra's. And then you used your 2 data structures to implement Google Maps. Very pretty project. Okay, I like it a lot. Now, what's different between this and NordNet? Anybody perceive what's different? Obviously there's some different stuff in it. There's one really, really big difference between this and project 2. Yeah. No, it wasn't really that. No, but there are some different content. Yeah. No public autograde. That's a big one. And I actually really like that. My TAs hated it. The students thought it was nerve-wracking. It's a deeper answer. Anybody spot it? Yeah. Less choice. Exactly. This project was very on rails. Build a KD tree, build a priority queue. This is the API. You have to implement A*. This is how you do it. And because of that, you were missing the experience of getting to do something new. And that only happened with project 3. So as you noted at the bottom of the slide, if you read ahead, that's the answer. That's why I changed this. Basically, project 2 was do what we did in lecture. And I was like, okay, I really like this, but I feel like when I interview people, for example, my side gig, I don't care as much that you've done this, right? What I care more about is that you've had to face hard choices about how to even approach a problem. And that's why project 2B is as it is. I want you to have the experience, even though it is scary. Okay, so I just feel like it's a slightly better use of time. But was this bad? No. And does it help you learn data structures better? Yes. They walked out of the class knowing exactly how A star works. Something you guys don't know is that to implement Dijkstra's, you have to have a priority queue with a change priority operation. Like you might have kind of picked that up, but never really thought about it. But if you really, really, really get that, I mean, or rather, to really, really get that, you have to kind of do it or have somebody point it out in the middle of a lecture brief. Then we had version 3.5. We're getting close to the modern time. So I had a pushback from my TAs at Project Zero. The old one was too easy. It was called InBody. It was very pretty. I still like it. It's not impossible that I'll go back. But the idea was we want something harder, something that's actually a design challenge. So my TAs convinced me and that happened. And then Project 2 in these two versions of the class, it was a more open-ended project. I wanted something more open-ended, the bare maps that has more data structures in it. Now, Gitlet, I did not want to do it spring 21. I actually have like an allergic reaction to Gitlet. I don't really like the project. I found it boring when I implemented it myself. Students really like it. The ones who get through it really like it. And a lot of my TAs like it. But this semester, they were just, all the TAs were trained on Gitlet because they taught with Paul for a year. So I was like, okay, we'll do it. But it didn't pay off for me. So the next semester, I went a little rogue and told by the way, one of the most conservative forces in a class is the TA pool. If we try to propose some big crazy thing, you get pushback. Like, well, we can't do that. That's not how the class works. Not like deliberately so, but it's just there's a resistance to like dropping a project that's beloved and known, like Gitlet. But I got everybody on board with NordNet, and we ended up voting after the semester to keep it 3-1. So I felt good that I'd put Gitlet to rest, which I didn't really like. Now, what was new about NordNet is there's more data structures than Gitlet, which isn't really a data structures project. And there's also a better ramp of difficulty where 2A is a little bit on rails and then 2B is off. Okay, so I'm pretty happy with NordNet for the most part, but I got to read the feedback more carefully from last semester and this semester to decide, is it truly the project? I don't know. What it lacks is a nice like super visual component. One thing I do like about it, and one thing that took me an enormous amount of time in the fall was building the web API. Or building out the website stuff, the JavaScript. Out of curiosity, how many people tinkered with the JavaScript code? Anybody really? Nobody? Or like played with the HTML? Anybody add the buttons? Yeah? Like, I think that's a nice thing. Even if you didn't all do it. Yeah, okay. Oh yeah, I'll give you a applause. Someone put I only applauded by myself though. You tricked me. Anyway, I think it's nice to get a sense of how to embed your code in a bigger system, even if I don't do it from scratch. Which brings us to some analysis that I found pretty interesting. I'm going to get to now in a second. One of the things about this semester that was really cool in spring 21 is we had some spyware in IntelliJ that students could opt in to provide us with their data. And what it would do is every single time you do anything, basically in IntelliJ, it would save a snapshot of what your code was doing. And so we had basically to the like 5 to 10 second granularity of all the students' project implementations. And we promised not to use it for plagiarism detection, and we never used it for that because probably there's a lot we would have caught, but I didn't care. All right. I mean, because it's rude, you know, like we're not going to watch over your shoulder, right over your shoulder, not going to do it. So one of the things we did is we figured out how many hours people spent on the old Gitlet. And what was kind of interesting is that the difference between the 25th percentile and 75th percentile was about a factor of 2. And this was a really interesting question for me because I've always wondered how much faster do the really fast students move than the slower students who came in with less experience or less mathy, less just well prepared for college in general, probably. And between the top and bottom quartile, it's about a factor of 2, which is not as bad as I had feared. Now, there are long tails that people have spent a lot of time, but they're relatively low. 120 hours is quite a lot of time to spend on a programming project. Okay? So this is a really cool project. I'm really glad we did this work. One of these days, well, I couldn't get an IRB, so publishing this will be hard, but I can tell you that. Yeah. The thing I always ask is I have these surveys, and thank you so much for the surveys, but I asked, was Gitlet healthy for you after it was over? Okay. So actually only a minority of students felt like the experience was healthy. And a lot of people did not think so. So I think NordNet, I should show the data. I think it's better, but Gitlet didn't feel right to me. Okay, so that brings us to today, this semester. So what's new? Well, one thing is we changed from JUnit to Truth, which is what's called a fluent assertions library. And these are a little more popular these days. So it's like assert that dot is equal to. just the tests roll off your tongue a little better. And you'll probably see this in the world. Okay. The thing is, we got rid of some of the really, like, I've been trying to kill off inheritance material, and my TA has actually been really behind me on this one and pushed me harder. So I got rid of some of the like corner casey language stuff because I find it very boring to learn. Okay. Next thing is we moved data structures way earlier. So we put lists and maps in lecture 2. And I actually really like that change. And it came with a couple of things. One was we had a new homework 0B to get some practice. And I was like, how hard is it going to be to take 2 lists and find all the items in common? Well, I mean, you've never seen Java in your life. Harder than I thought. So oops, sorry, that one was too hard. So I always front load the class. But for those of you who are new to Java, we way front loaded it. The other thing is we made a new project 0 to use the data structures in an interesting way. And I just like obliterated a large fraction of the class. I feel very bad about it. Now, one thing to note is I was very worried about the project scale and did scale it back a little bit. There were a couple of key things. One was I switched the order of the guesser and so this assignment already existed at Caltech. It was adopted from a Stanford assignment that a colleague of mine, Keith Schwartz, put together there. I switched the guesser and the chooser. So the guesser came earlier because it's like, oh, you know, it's like a little more straightforward than the chooser. But at the Caltech assignment, the guesser was somewhat optional, and it's actually pretty hard to get right, as you learn. The other thing was, I think Caltech students just generally come in, like the bottom half of Caltech students probably tend to have more STEM programming background or whatever. And so the students who came in less prepared, who just only come from 61A, and maybe not with like an A in the class, it was just hard for them. Okay? Added partners for project 2B. The basic idea is there's some design. So it wouldn't be fun to talk to someone else. But the downside is, of course, maybe you get a little less like doing the thing. Maybe you get carried. I don't know. Who knows? Anybody here get carried on project 2B? Hey. So that's a good thing and a bad thing, right? You might learn a lot, but I'd say it tends to be bad. Unless you have other things, cool things going on in your life. And then we had a couple of new labs. We had a new debugging lab, which solved a long-standing puzzle of how do we teach debugging well. Thank you, TAs. And then we had the new lab on getting started with project 3, which I love. Yeah. And we had a new lateness policy. And I have a new lateness policy every semester. So what do I have to say about it? All right. Any questions about anything? So these are all the things about course design. I'll have more stuff to say, but anybody have any questions about like why things are the way they are or suggestions? You like them? Okay. Yeah. The people in the front row like it. Okay. Yeah. So, yeah. Oh, the inspiration for the projects is I have kind of an interesting idea and then I try and build it. And if it's kind of fun and I like convince myself that it's actually enjoyable, then I just keep going until I build something. Yeah. But it's just kind of a gut feeling. I don't know. But I've been doing this a long time now, like 12 years. So yeah.
So you said the product service hard. I mean, I think the thing is like I look at, I mean, I was one of those people who have like CS16B as a product. You do projects there, and I was just I'm gonna do it anyways.
Right.
Like it's like I didn't have a concept of like it's too hard.
Yeah.
Projects, but like you said that it's too hard.
Ah, okay. Didn't feel too hard till you said it was. So I think there were other people that really it was too hard because the deadlines were slipping by and people weren't done yet. Yeah. Right. Right. You're an optimist, I think is what I'm hearing here. Yeah. I mean, I think with more time, probably all of you could have finished it. It's just the time was tight given what you had to do. Yeah. Good.
Industry practices influence the content that we learn, and generally, what is that insight coming from?
This is an interesting question. So I inherited the way that I think about testing. It was kind of a mix of working with teaching assistants and a little bit of Paul Hilfinger's. But like at Princeton, we didn't have unit testing at all. And there wasn't a sense of like building confidence in the basic building blocks to your code. And I think it's one of the biggest flaws of the class. And I'll continue to harass Kevin Wayne until he introduces unit testing into Coast 226. But that to me, like this whole sense of the decomposition part in the testing, I guess I picked it up from my own instructors and a little bit from my TAs. Now, what I was delighted by, and I mentioned this before in class, is that now that I've been doing a little bit industry coding, I find these practices enormously helpful. Like it's it's good stuff. So I mean, I now have a solid year of industry experience, so 8 hours a week, and yeah, seems like it's working out well. So my own practical experience and the teachers before me, my own industry stuff. Yeah. Right. I would say, I think it's a great exercise, but not the best use of scarce semester time. Because the actual limiting reagent in terms of what we get done in the semester is your time, right? And I just don't think you get as much out of it. But I think if you want to, a good thing to do after this class, if you were like really just, I don't know, I got time to kill and I gotta be ready for job interviews or whatever, you could try doing that. Actually, Keith Schwartz, who I mentioned earlier, who did the original Project Zero, when he was a grad student or maybe an undergrad, he went through and did something interesting where he just implemented a bunch of different data structures. Let me try and find this thing. Archive of interesting code. So Keith is like super, super hardcore, by the way, but he basically went through and wrote like his implementation. You see, these are all old when he was an undergrad, or maybe he was a 5th-year master student then, but yeah. So I don't know, make your own keithschwartz.com/interesting. You have to spell your name differently because he owns this domain. Okay. Yeah. Questions? Yeah.
What would you say is the one thing you wish you could have taught us that you didn't? Maybe like either like for the experience, like
Oh, that's really interesting. Okay. Okay, sorry, I was looking at the wording my thing. Okay. I mean, honestly, I think it would be some sort of even bigger, more collaborative project, like groups of 3 that interact with other groups of 3. So you have like different stakeholders and you got to like figure out your APIs across. That would be really fun, especially if one of the things you could do is also like an open GPT groups of like 3 groups of 3 type assignment. That would be one thing I do. It would be really fundamentally different. Yeah. And useful. Yeah. 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 The course description predates me, right? The thing about, right, yeah. The coupling between the description and what I do is very loose. Yeah, so it's not very well enforced by anybody. Go ahead, yeah.
With these like lower division CS courses, how much of it is really like trying to teach us how to program versus teaching us these like more abstract critical thinking skills that you were talking about, like decomposition and abstraction?
That's interesting. I think, well, if I only tried to teach you abstract critical thinking, it wouldn't work because there'd be no there. So I would say the writing of code is actually pretty easy. The construction of like mental models that you need to translate into code is the hard part. At first, the programming part feels hard because you have to know what the constructs are. So I would say that it's like when you learn language, how much of it is learning how to move your mouth to make, you know, like blah, blah, blah sounds? And how much is it the ideas? The blah, blah, blahs have to come first. I guess that's kind of a weird answer, but the best I could do. Yeah. Java is a good language because it is statically typed and it is very popular. Yeah. Yeah.
Do you have like a mission statement?
That 16B has no mission statement, but my goal is to transform your brains in a way that's not too painful and pretty fun along the way. Yeah. Good. Yeah, I'll do.
what is the expected percent of people who are supposed to get a 3.3?
I think a B, I've forgotten the number. B plus is like, you know, it's more than half of the class, a fair amount more. I don't think that 3.3 GPA is itself a significant barrier. Like, I think most people who really decide they love it end up even making it in through appeal if they don't make the 3.3. But I think there are people who, because the barrier exists or they have a bad time in the early classes, do drop out. I think the attrition rate, because there is a bar at all, is probably around 30%. So this is, of course, going to be obsolete very soon. Yeah. static typing is related to this class because this class is about managing complexity in large software, and static typing is a great tool for that. Because the thing is, when you have a function in Java, you know what you're getting, whereas in Python, you don't. So when you go back to writing Python, if you haven't written in a while, like if you take 188 after this class and you're doing the assignment where you're implementing A star, you're going to be like, what is the thing I'm being given? It's just called X. It's a little frustrating. Is it a function? Is it a list of numbers? Is it 3? Yeah. I'm gonna stop typing.
How is next
I mean, I don't know what the scale is going to be. I'm hoping the scale is similar next year, but I don't. How do I design for scale? I mean, it mostly just comes down to like trying to do as good QA as possible on assignments. Because if anything can go wrong, it will go wrong. And when I write exams for this class, I like to write weird exams. Not that you've really dealt with my exams, actually. But it's always challenging to make things that are clear, but also weird. And any single misinterpretation that's possible in a large class will be made. Yeah. I'll take one more question, I think. Yeah. Yeah. That's a good question. 61A influences me because I need to know what's in there in order to teach it effectively. So I just assume that you guys know trees and recursion, that sort of thing. We don't know trees that well, but like having a deep comfort with recursion, having played around lists, pretty important ideas. 61C, I like to give call outs to things you will learn, but I think the class operates semi-independently of the two. Any questions from over here since I said it? All right. Okay, I'll talk about one more thing probably. Oh, by the way, here's the list of everything that's changed every semester if you want to look at it. Okay, let's talk about the workload. So right before I taught 61B the first time, summer 2014, I posted on Reddit, hey, I'm teaching 61B, tell me what you think. And one of the top pieces of advice, though the post has since been deleted, was please keep Hilfinger's projects because it's like a transformative thing. There was a student here who said, definitely this, keep these projects. I wouldn't have learned as much if it weren't for the projects. Hilfinger 61B has a way of making you feel inadequate, completely inadequate until you finish the class. Then you feel like a programming god. So I don't strive for this as extremely so as this student states, but I still have a baby version of this in my mind. Actually, there's another story I always tell that in the fall of 2014, my first time code teaching with Hilfinger, I had a student who, sorry if I've told you the story before, she left the room crying suddenly. I was in lab, it was the evening because I didn't have kids, so I could just show up in the lab and see how people were doing. And when she came back, I was like, are you doing okay? Like, what's up? And the issue is that she had finally passed the auto grader. Like, that's why she had left the room crying, because it was just so intense, right? And it's like, is this a good thing or a bad thing, right? Like, I thrive on really challenging, difficult situations. I like losing. So I liked playing StarCraft when I was younger. It's why I like playing video games for the Nintendo Entertainment System when I was a kid. It's why I like surfing, because these tasks are all very difficult. And I like being beaten down by the universe and surmounting the odds. That's just my personality, but that's not everybody. So, I would have loved that experience, but I know everybody does. Yeah. All right. So when I think about workload, this is a typical weekly survey result for this class. How do you feel about the pace of the class? Basically, nobody says it's too slow. There's a few, but not many people think it's too slow. A lot of people think it's like good or a little faster than I want, or like kind of heavy duty, or like even pretty heavy duty. And maybe 10% or so of students are like, I'm just drowning here a little bit, right? Now I could shift this distribution to the left, and I have since the earlier days. And this is one of the hardest trade-offs in this class is people come into the class from all kinds of different backgrounds, and they all have 15 or 17 weeks to get done, right? I think these students could all do very well. They just don't necessarily have the time and the background to do it. So I have this interesting challenge that this picture right here is that's called the zone of proximal development diagram. So here's stuff you can do unaided, and this is a waste of your time. If I give you an assignment and you just do it and you don't have to think, then you've gotten some points and maybe it feels good, but you didn't necessarily learn very much. On the outer edge is if I on day one just gave you Gitlet or something. Like you couldn't do it, period. You can maybe get fairly far, but I don't know, probably not. And then we have the zone of proximal development where we give you some degree of guidance, and way on the outer limit is, when you need to sit at office hours all day. And the inner limit is going to be, there's some scaffolding for the project that gets you there. Okay. So I try and keep you in this range because that's the sweet spot. Now, one thing I did actually when I was tuning the workload and based on the spring 2021 data, in theory, you're supposed to spend around 12 hours a week on the class. This is how roughly that would be broken down. And so what that means is that the total time you spend doing some kind of programming should be around 6 hours a week. So I did an experiment, or like I looked at the data we had to see how close are we to that. So here's a box plot. And this is from spring 2021. What these box plots mean, if you've never seen one of these, this middle line is the median. This is the one of the quartiles. This is the other quartile. This is what's normal. I'm not going to explain it. It's an interquartile range. I'm not going to explain it. And then we have the outliers. So for example, in week 5, when project 1 that semester was due, the student who spent the most time in IntelliJ spent 39 hours, which is well in excess of 12 hours, or sorry, 6 hours a week programming. But yeah, and like the theory, the median should be around 6 if you were going to stick to this schedule. Okay? Now, if you look across the entire semester, the median across all the weeks, including the weeks where we were doing no programming because there was a midterm or whatever, across these 12 weeks was around 4.3 hours. During Gitlet, though, it went way higher, right? The median number of hours people spent was 11 hours, 10 hours, yeah, in that week, okay? With some major outliers, okay? So it's kind of interesting. Like in the middle of the distribution, we were doing roughly right, but it does feel like, you know, based on this and like this data here and this data here, maybe 61B is like a little too much, but I tend to err on the side of a little too much than a little too little. Okay. So I just want to say, like, I generally find it a waste of time for you to do work that's either too easy or too hard. And really, in a better universe, what I would like is a variable amount of time. And we can take the class at a pace you can handle. Of course, having the deadlines, like, who else is in the club that you only get work done when deadlines are like 2 hours away? Only this part of the room. Okay, how about within a day? Like a deadline within a day gets you going. Yeah, super important for me. So maybe that's okay. We have some time constraints. It's a delicate dance, right? But if you're one of the people that has a tough time, you're probably not someone who comes to lecture now. Sorry, but you know, I'm thinking about you. All right. Any reflections on workload or anything you want to report out? No, it's fine if not. Keep up with lecture well. Right, practice and midterm seems hard. I'm going to throw out my favorite piece of advice, which is my favorite way to study for exams, is to do problems with other people and debate your approaches. It's really good. It's hard to do, but it's a good strategy. Yeah. I don't know anything about the midterm review sections and how well they work. Totally outside of my ken. Yeah. Mm-hmm. Mm-hmm. Project 2B, well, the way I think about it is you have to decide how you want to implement a graph and how you can implement the algorithms and get sort of a smaller version of the complexity battle you get out of Project 3. That was the goal. Yeah. But maybe I didn't quite hit it. I'm a semester behind on reading the feedback carefully. Project 3, I love. No, Project 3 started in 2018. It was kind of a fever dream where I was just like, I'm going to try and do this thing. It's like, yes, this is feeling real good. And then like the ratings for Project 3 are so much better than the other projects that it makes me feel like the other projects could be much better. Yeah. Yeah.
Like more stuff, like after, especially after your project, I was like thinking like, oh, I feel like told me like, oh, try to answer. I would actually try.
Right. I'm glad that I pushed you to do huge things. Yeah. Yeah.
Extraordinarily poor.
Yeah.
Like I literally locked myself in a room with my partner for 2 weeks and spent like 6 hours on finishing the entire
Mm-hmm. Yeah.
And like the last few hours of just debugging was not a problem. We fixed the problem like super early on, but then we were afraid to like use all the tokens to use it. So we could just keep looking at the code. Okay, something's wrong.
The autograder token scarcity had you looking at your code too long. Okay, I'm actually going to skip to the very end and just say like, if anybody's, I'm going to skip the section on staffing, and I'm just going to go straight to anything else. Yeah, yeah. So I'll take like open comments, questions, whatever. Yeah. All right, got a 7-hour stretch coming. Great. All right, good luck. All Yeah. Is anybody over here I haven't heard from yet? I mean, I'll take you guys. Yeah. So other statically typed languages, I mean, like C++ is a real big one. C, Java, Kotlin. I mean, there's a lot of popular ones. Then there's like the extra. They're not really more statically typed, but there's a flavor of languages where the typing is even stronger, like the ML languages, where it's just there's certain bugs, like null pointer exceptions are very difficult in those languages because the language is very picky about nulls being passed into things. Yeah. Yeah. Right. Right. So that's a really interesting point. This idea that debugging eats a disproportionate amount of your time. And I think it's a lot of office hours time. I think it eats a huge amount of budget. And I still kind of feel like there's an opportunity for really good debugging tools that are for pedagogical purposes. Like we've been talking a little bit about, could you bend GPT-4 into being a useful debugging tool in some way? I don't know. Yeah.
I think all like learning about all this data structure stuff was great, but probably the most valuable part of this course to me was like collaborating on projects with these and realizing for the first time that this is a project I actually need to write code.
Right.
There's 61B really in mind. 61B, you have to sit down and code a file of hot garbage that has.
Right. Yeah. So there's the pile of hot garbage problem before 2B. Yeah, I mean, I couldn't have said it better myself. And that's one of the things, like, I really like teaching 61B because it's that point where you learn how to swim, right? You learn how to get dropped in the morass of complexity and somehow extricate yourself. So yeah, happy to bring you there. Okay, that's all I got. I had some more slides on staffing if you're curious about how staff design goes, but that's it. See you on Monday. What are we gonna do? We need theory time. Yeah.